we have here a position function for a rock, and we'd like to find average velocity. And so we need to know the formula for average velocity. That's just the change in the position, so h of t2 minus h of t1, and divided by the change in time, so t2 minus t1. So this is average velocity. Average velocity. So for part A, we'll do that for these different time intervals. For the first one, we'll start with h of, now our time period begins with time t equals 1 and lasts 0.4 seconds. So we'll have a 1.4 and then minus h of 1 over 1.4 minus 1. So plugging this all in, we'll have h of 1.4 is 10 times 1.4 minus 3.1 times 1.4 squared. That's h of 1.4. And then minus h of 1, which is 10 times 1 minus 3.1 times 1 squared. And we're dividing this by 0.4. Now we're going to work through this on a calculator. So we've got 10 times 1.4, which is 14, minus 3.1 times 1.4 squared. And then we have a minus a 10, and then plus a 3.1. And we take that and we'll divide by 0.4. All right, 2.56. Okay, and let's put our units on this. We're looking at t's in seconds, and we've got here meters. So this is meters per second. And we'll do the same thing for the others. So here we'll be doing h of 1.1, because again our time period starts with 1 and lasts 0.1 seconds. So at the end of our interval we're at 1.1, and then minus h of 1 over 1.1 minus 1. So that's 10 times 1.1 minus 3.1 times 1.1 squared minus, and then this is actually the same thing every single time because it's always going to be h of 1. So that's just going to be 6.9 every time. And then over 1.1 minus 1, which is 0.1. All right, so let's do this again with the calculator. We got 10 times 1.1, which is 11, minus 3.1 times 1.1 squared, and then minus 6.9. And then we'll take that and divide that by 0.1. 3.49. And again, that's in meters per second. All right. For this third one, we have h of 1.04 minus h of 1 over 1.04 minus 1. So that's 10 times 1.04 minus 3.1 times 1.04 squared minus the 6.9 over 0.04. So 10 times 1.04 is 10.4 minus 3.1 times 1.04 squared minus 6.9, and then we'll divide that by 0.04. We get 3.676. And that's meters per second. And for the fourth one, we have h of 1.01 minus h of 1 over 1.01 minus 1. So that's 10 times 1.01 minus 3.1 times 1.01 squared minus the 6.9 over 0.01. So 10 times 1.01 is 10.1 minus 3.1 times 1.01 squared minus 6.9, and divide that by 0.01. 3.769. Again, meters per second. All right, so we want to know kind of what this is approaching. For part B, we want to estimate the instantaneous velocity when t equals 1, and looks like we've been increasing here, and we just want to estimate, and so my estimate is going to be maybe a 3.8. So instantaneous velocity, at t equals 1, we'll say is approximately 3.8. Okay, that's our estimation. Because it looks like these are kind of getting bigger and closer to 3.8. And we could check that if we wanted by picking smaller and smaller time intervals. But I think this is a good enough approximation.